Hello, algebra students. This is still a continuation on section 8.5 where we were adding and subtracting rational expressions. Only now I want to focus on something that we're going to call complex fractions. And so we're still going to look at some kind of easy non-rational expression example first, and then see if we can extrapolate that to look at the ideas that we're studying in section 8.5. So if I had told you guys to divide 2/3, take 2/3 and divide that by 6/11, and presented it to you like this, and asked you guys to not use a calculator, I think you would probably struggle with this question because you probably haven't seen it in this form. We have 2/3 and we are dividing it by 6/11. Now, here's a pretty easy trick that you can do if you're ever presented with this type of question. Basically what it is to take the top one and the bottom one and multiply those two things together, and that's going to be your numerator, like that. 2 times 11, 22. And then take the middle two and multiply those ones together, and that's going to be your denominator. So 3 times 6, that would be 18. And so 2/3 divided by 6/11 probably wouldn't have had any idea how to do it, but realistically, super easy. Take the top and the bottom one and multiply them. That's your numerator. The middle two, multiply them. That's your denominator. We would, of course, have to reduce this fraction to 11/9, and we'd have our answer. Now, you might not be this type of person, but in case you are, why is that working? Remember, to divide, this is the same question as this. 2/3 divided by 6/11. Right? 2/3, take that fraction and divide that by 6/11. We did this in the last section, section 8.4, where we have to keep this one, turn it to multiplication, and then flip it, and that's exactly what we end up doing. If we were to take 2/3 and multiply that by 11/6, we would have 22/18, the exact same thing. But I do want us to use that trick as we look at these things that I'm going to call complex fractions, where you have something like 5 over x plus 4, which is being divided by, and then we have these rational expressions being added to one another from this section, section 8.5, the part A, and we have to somehow figure out how to add them. Here's my steps for us. Combine all fractions using subtraction and addition. The stuff from the first part of this lecture. Use that. Our numerator here, this part, 5 over x plus 4, that is already combined. We can't combine that further at this time. But my denominator here, this 1 over x plus 4 that's being added to 2 plus x, that needs to be simplified using the concepts outlined in this section. So our denominators don't match. This one, in order to match, would need an x plus 4 over x plus 4. And this one would need an x over x. So an x in the numerator and an x in the denominator. I'm going to rewrite this whole statement to say 5 over x plus 4 is being divided by, on the left part we have 1x, or just x over x plus 4, and that's being added to, I'm going to go ahead and distribute this 2 in because I want to be able to add this x to it. So that would be 2x plus 8 over x plus 4. Remember, that's the whole goal. I said that over here. I want to combine my everything to look like the numerator here. So this one is almost there. It's now 5 over x plus 4, which is going to be divided by 3x plus 8 over x plus 4. Now I have a fraction that is being divided by another fraction. Before, back up here, I had a fraction that was being divided by fractions being added to one another. Now I don't have that issue anymore. So what I'm going to do is I'm going to take the top and the bottom one and multiply these together. If I were to write that out, that would be 5x times x plus 4. 5 times this, x plus 4. I could distribute it if I wanted to, but I actually don't want to because I like it factored like this. My now middle two are also going to be multiplied together. X plus 4 over 3x plus 8. And that's going to go in the denominator. Boom, boom, boom. Now, they have an x plus 4 in common, and that can be canceled. And I just end up with the answer of 5x over 3x plus 8. Remember, I can't do anything because there's like implied parentheses here. That's just my answer. So it looks horrible, but if you take this step by step, I think these questions aren't too bad. I just have one more for us to try. Once again, the numerator is totally fine. This is simplified, but my denominators do not have the same denominator, essentially. This one has an x plus 5, but this one doesn't, so I'm going to multiply by x plus 5 over x plus 5. And this one is missing an x minus 3 over x minus 3. I'm going to rewrite this nice so I can see it well. I have 3 over x plus 5, and that's being divided by. Over here, my denominator of this part is x plus 5, x minus 3. This is going to end up being added with another x plus 5, x minus 3. I'm going to simplify my numerators a little bit. I can distribute that 1 in and just get x minus 3. I can distribute the 2 in over there and get 2x plus 10. Once again, my numerator part, the 3 over x plus 5, is completely fine. But now now that my denominators match, I'm going to add the numerators, and I would get 3x plus 7. My denominator, of course, would be x plus 5 and x minus 3. Now I have a fraction that is being divided by another fraction. So all you do, once you're here, is take the numerator and denominator and write those together up top. 3 times x plus 5, x minus 3. And that is going to be divided by, now these two get multiplied together and written in the denominator, x plus 5 and 3x plus 7. I'm going to look for some cancellations, and there is one there, the x plus 5s. So my final answer would be 3x minus 3 over 3x plus 7. Remembering there is implied parentheses here, so I can't cancel those 3's or anything like it. That's just my answer. So this has been the second part of 8.5, the complex fractions. Please let me know if you have any questions.